Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
In a groundbreaking advancement, the James Webb Telescope, positioned at the vanguard of cosmic discovery, has captured a signal of extraordinary importance originating from the far-off Andromeda Galaxy. This celestial message has ignited the global scientific community with excitement, fueling a whirlwind of conjecture and fascination. Is this an unusual cosmic occurrence or evidence of intelligent extraterrestrial beings? Embark on this journey with us as we delve into the revelation that the James Webb Telescope has detected a startling signal from the Andromeda Galaxy. Chapter 1. Magnificent Secrets of Andromeda Galaxy. Andromeda, our nearby galactic neighbor, boasts a multitude of special characteristics that captivate astronomers and differentiate it from other galaxies. To start with, Andromeda's sheer size is impressive. Recent data suggests it stretches across about 220,000 light-years in diameter, making it one of the biggest galaxies in our cosmic neighborhood and similar in size to our own Milky Way. Its large dimensions are home to an estimated 1 trillion stars, outnumbering those in our galaxy. But size isn't the only remarkable aspect of Andromeda. The structure adds another layer of passion. While it sports the classic spiral shape common among galaxies, Andromeda has its unique qualities. It flaunts a swollen center and a dense core encircled by bands of dust and gas where stars are actively being born. These characteristics hint at a lively galaxy with constant processes shaping its appearance and evolution. The core of Andromeda holds particular allure due to an unusual feature known as double peak emission, hinting at the possible existence of a supermassive black hole. This event parallels what they've observed in the Milky Way. But studying Andromeda's black hole provides vital insights into these mysterious entities. Furthermore, Andromeda isn't alone in space. It's enveloped in a vast halo of stellar matter stretching hundreds of thousands of light-years. This halo comprises stars, planetary nebulae, and globular clusters, offering a look into the galaxy's detailed history and formation process. The clusters of stars, called globular clusters, are particularly interesting to scientists. There are more than 460 of these clusters in Andromeda, and they provide valuable information about how galaxies like ours were born and how groups of stars behave together. Another interesting aspect of Andromeda is its collection of smaller galaxies that orbit around it like satellites. There are over 20 of these smaller galaxies, and some of them are gradually losing their stars and gas as they get too close to Andromeda. This process, known as galactic cannibalism, shows how galaxies can grow by swallowing up smaller ones. But what's even more captivating is how Andromeda is changing and what its future might be like. Scientists are strongly curious about this and are studying it closely. One big change that might happen to Andromeda is that it could transform from a spiral galaxy into a ring galaxy. Observations hint at shifts in its structure that could lead to this rare form. Ring galaxies are pretty special and usually happen after galaxies collide or nearly miss each other. So, if Andromeda is heading towards this transformation, it suggests that it's had some close encounters with other galaxies in the past. Andromeda's future is also tied to our own Milky Way galaxy. Scientists predict that in about 4 billion years, Andromeda and the Milky Way will collide and merge. While this might sound like a cosmic disaster, it's a normal part of how galaxies evolve. Thankfully, because of the vast distances between stars, the collision won't involve stars crashing into each other directly. It's a slow dance of gravity, reshaping the galaxies over millions of years. However, when the galaxies come together, their combined gravitational forces will have a deep impact, reshaping them dramatically as they merge. The gas and dust within each galaxy will collide and interact, sparking off fresh waves of star formation. This rise of star birth will illustrate the merging of galaxies, resulting in an extraordinary celestial display unlike any other in the universe. This event holds a special significance for us humans, due to our direct observation and involvement. Moreover, the supermassive black holes situated at the centers of both galaxies are poised to merge as well. This union may unleash significant emissions of radiation as the surrounding matter is consumed by the newly formed black hole. So, what lies ahead for the fate of our solar system amidst the impending merger of Andromeda and the Milky Way? Michio Kaku reveals that while the annihilation of the solar system is improbable, its circumstances and position are likely to undergo considerable changes. These changes could manifest as shifts in orbit or even expulsion from the newly formed galaxy altogether. Understanding these complicated processes not only aids scientists in foreseeing the outcomes of similar happenings elsewhere in the universe, but also furnishes vital context for understanding the eventual destiny of our very own galaxy. Chapter 2. The Cosmic Lens. Long ago, when early astronomers peered into the night sky, they saw the Milky Way as one big blob of light. They didn't have fancy tools to see individual stars, but along came Galileo Galilei with his telescope in the 17th century. He showed them that the Milky Way is a collection of countless stars. This blew people's minds and made them wonder if there was more out there. Then, in the 1920s, Edwin Hubble rocked the world of astronomy with his powerful telescope. He spotted galaxies far beyond the Milky Way. This was groundbreaking. One of these galaxies was Andromeda, also called M31. Even way back in the 10th century, before telescopes, a Persian astronomer named Abd al-Rahman al-Sufi saw Andromeda as a faint smudge in the sky. As technology advanced, scientists got better at studying Andromeda. They realized it was not just a blurry patch in the sky. It was a massive galaxy like our Milky Way, but incredibly far away, about 2.537 million light-years. They've gone from winking through telescopes on the ground to using cutting-edge space observatories like the Hubble and the James Webb Space Telescope. These telescopes let them peek deeper into the mysteries of this distant galaxy, unraveling its secrets one star at a time. Each time they invent a new tool, they get closer to fully understanding what Andromeda is all about. Knowing how Andromeda is put together and what it's made of helps scientists learn more about the whole universe. It's like having a big puzzle, and understanding Andromeda is like finding a piece that helps them see the bigger picture. Plus, it's like having a twin galaxy to the Milky Way so they can compare them and figure out how galaxies form and change over time. The James Webb Telescope is like a superhero telescope compared to the older ones, and it's found some really interesting stuff in Andromeda that's shaking up what they thought they knew. This super telescope has spotted some weird stuff going on right at the center of Andromeda, stuff they've never seen before. Scientists all over the world are scratching their heads over this. The signal suggests that some really important things are happening inside the galaxy, maybe something to do with its super huge black hole or something they've never even imagined. One of the big discoveries is that Andromeda might not be as big as they thought before. They thought it was way bigger than our Milky Way, but now with new measurements it looks like they're more similar in size. This changes everything about how they see our galaxy in the big galactic neighborhood. Furthermore, the James Webb Telescope has given them clearer pictures and information about Andromeda. These reveal fresh details about how stars are born and what elements make up the galaxy. Another interesting find concerns the active heart of Andromeda, called its galactic nucleus. The data shows that the black hole at its center is more active than they previously thought. This heightened activity doesn't just stay put. It affects the space around it and could even shape the future structure of the entire galaxy. The telescope's observations also shed light on the mysterious dark matter. Kaku mentions that by studying how Andromeda stars move under its gravitational influence, scientists can get a better grasp of how dark matter is spread out across the galaxy. This is crucial for tackling one of the most puzzling questions in astronomy. What exactly is dark matter, and how does it influence the universe? These recent revelations from the James Webb Telescope have sparked a flurry of research. Scientists all over the world are delving into the data, eager to unearth more of Andromeda's mysteries. Each discovery adds another puzzle piece to their understanding of the galaxy's past and future, painting a clearer picture of how the universe operates. Chapter 3: Andromeda and the Milky Way Galaxy. Studying how Andromeda will change in the future is like trying to figure out the big forces and changes that happen to galaxies over many, many years. It's like watching a slow-motion dance of stars and planets, trying to understand where they'll go next. They're particularly curious about what will happen when our galaxy, the Milky Way, and Andromeda merge. It's like two giant cities coming together. There's bound to be some commotion. When they say merge, they don't mean stars crashing into each other like in a movie. Instead, it's more about the big invisible forces at work. Imagine two giant magnets getting closer and closer. They might not touch, but they'll feel each other's pull. This merger could shake things up in our cosmic neighborhood. Stars that once had predictable paths might go spinning off in new directions, including our own sun. And if our sun moves, Earth might feel the effects. If Earth gets closer to the sun, it might start feeling like a hot summer day all year round. That could mean trouble for polar bears and penguins as their icy homes melt away. But if they move farther away, they might need to break out the winter coats for an eternal frost. This galactic mashup could also bring more radiation their way. As the black holes in both galaxies get cozy, they might start flinging particles around like cosmic slingshots. That could mean more cosmic rays zipping through our atmosphere, which might not be great news for life on Earth. The increase in radiation could harm the delicate balance of life on Earth, affecting how living things grow and survive. This could mean more changes in how animals and plants look and behave, and it might make some species disappear forever. Imagine Earth like a big puzzle. If things like our orbit or how the planet tilts change, It's like shaking up the puzzle pieces. Some creatures might find their homes no longer fit together like they used to. This could cause a lot of animals and plants to move around or even vanish. But it's not all bad news. Some creatures might find the new conditions perfect for them. However, for others, it's like a nightmare they can't wake up from. Also, when two galaxies come together, gas clouds crash into each other, creating new stars. If these new stars form near us, they could shower Earth with a different kind of light and heat, changing the weather and life here. According to Michio Kaku, these big changes won't happen for billions of years. By then, humans might look very different or be living in far-off places in space. And what they learn from studying other galaxies like Andromeda can tell them a lot about our own home in the universe and what might happen to it someday. Comparing Andromeda with the Milky Way helps scientists learn more about how spiral galaxies are shaped and change over time. When they study Andromeda, they look closely at its spiral arms and the activity happening around its supermassive black hole. These features serve as a sort of guide for understanding similar things happening in our galaxy, the Milky Way. This kind of comparison helps scientists improve their ideas about how galaxies move and develop. Finding out how big Andromeda is and how much it weighs gives them clues about the Milky Way too. This shakes up what they used to think about the Milky Way's place in the group of galaxies around them and how much it affects them with its gravity. Right now, the Milky Way is a kind of spiral galaxy with a bar across the middle, but interactions with other galaxies, especially Andromeda, could change its shape. Learning about how Andromeda changes over time helps them guess what might happen to our galaxy. Scientists can use this knowledge to imagine what will happen when the Milky Way eventually crashes into Andromeda. Chapter 4. The Mysteries of Andromeda. Recent discoveries from the Andromeda Galaxy hold big meaning for the understanding of space. These findings give them crucial information about how galaxies are born and change. When scientists study Andromeda's shape, they learn how galaxies grow over billions of years. This includes how spiral arms form, how the swells in the center grow, and how crashes and mergers shape galaxies. Knowing these things about Andromeda helps experts make better guesses about how galaxies everywhere change over time. Andromeda's discoveries also help them measure far-off distances in space. Scientists look at how far away things are in Andromeda and compare them with other galaxies. This helps them improve the way they measure how much space is stretching out, which is important in space science. It's called the Hubble constant, and it helps them understand how fast the universe is expanding. Plus, when scientists look at the stars and the stuff they're made of in Andromeda, they get clues about how stars live and die and how different elements spread out in space. This helps them understand how things were in the early days of the universe and how they are now in galaxies. These discoveries about Andromeda aren't just for scientists. They also make people excited about space and help teach folks about it. Exploring Andromeda is like using a cool tool to show people all the amazing things in space. When they see awesome pictures and learn about Andromeda, it makes them wonder about the universe and all its mysteries. Public talk shows, planetariums, and news stories about the latest discoveries regarding Andromeda captivate people of all ages, sparking a deeper interest in astronomy and science as a whole. Many educational programs use Andromeda to teach basic astronomy. These initiatives serve to enlighten both students and the wider public about essential concepts in astrophysics, such as how stars form and die, how galaxies come into being, and the mysterious role of dark matter. Moreover, the power of social media and online platforms has revolutionized the distribution of Andromeda-related discoveries. This accessibility ensures that people globally can stay alongside the most recent developments in research and exploration. Amateur astronomers contribute reasonably to engaging the public with Andromeda, utilizing community observatories and participating in astronomy clubs. These enthusiasts observe the galaxy, partake in citizen science projects, and share their adventures with others. This hands-on involvement cultivates a sense of belonging within the community and enables a lifelong passion for learning about the universe. The educational outreach extends even into formal schooling environments. Modern curricula increasingly incorporate the latest astronomical findings, using Andromeda as a tangible context to teach scientific methods and critical thinking skills. This practical application of scientific knowledge motivates students and aids them in sensing abstract concepts more concretely. Furthermore, the depiction of Andromeda in various forms of media, including films and literature, underscores its cultural importance and its significant impact on the collective imagination of the public. In stories and books, the Andromeda Galaxy has been a popular backdrop for many exciting science fiction tales. Writers often choose this vast galaxy as a setting to delve into ideas like exploring unknown territories, encountering strange creatures from other worlds, and pondering the vast mysteries of space. These tales not only captivate readers but also spark curiosity about astronomy and the real scientific wonders tied to the Andromeda Galaxy. Movies and TV shows have also taken audiences on thrilling journeys to Andromeda, where they encounter bizarre alien life forms and grapple with the daunting challenges of traveling between galaxies. Even though these stories are made up, they make them wonder about where they fit in the grand scheme of the universe and whether they are truly alone. Through the magic of cinema, filmmakers provide a visually stunning way for people to consider these cosmic questions. In the realm of video games, Andromeda serves as a rich playground for players to embark on epic adventures and daring space missions. Gamers get to pilot spacecraft, meet strange extraterrestrial races, and unlock the secrets hidden within the galaxy's depths. These interactive experiences let players immerse themselves in the wonders of Andromeda, sparking their interest in real astronomy along the way. With captivating visuals and expert insights, they make complex astronomical concepts easy to understand and captivating for a wide audience. Now it's time for today's subscriber pick. In the vast expanse of space, where mysteries lurk in every corner, humanity's quest for understanding has just taken a thrilling turn. The James Webb Space Telescope has just intercepted an alarming signal from the heart of the Andromeda Galaxy. The signal arrived as a burst of encrypted data, leaving scientists and stargazers alike bewildered. This message, according to astrophysicists, could be carrying whispers from billions of light-years away. But what could this signal mean? Is it a call from an advanced civilization, or a cosmic anomaly challenging our very understanding of the universe? What do you think this signal could be? Let us know your thoughts in the comments below. Chapter 5. The Evolution of Astronomy. Astronomy has undergone remarkable transformations, all thanks to advances in technology. From the earliest telescopes to the highly advanced observatories of today, each step forward has enriched the comprehension of space. It all began centuries ago with the creation of the telescope in the 17th century. This simple yet revolutionary device, made up of lenses within a tube, opened up new lookouts for astronomers, enabling them to witness Jupiter's moons and the changing phases of Venus. Over time, telescopes evolved in enlightenment and capability. The 19th and early 20th centuries witnessed the emergence of larger, more powerful telescopes, empowering astronomers to peer deeper into the universe and stumble upon new celestial entities like Neptune. However, these ground-based telescopes faced limitations, mainly due to atmospheric disturbances and light pollution. Michio Kaku hails the debut of the Hubble Space Telescope in 1990 as a great leap forward. Orbiting beyond Earth's atmosphere, Hubble bestowed upon humanity clearer and more serious glimpses of the universe than ever before. Its discoveries have been crucial in unraveling mysteries surrounding black holes, the universe's age, and the vast expanse of space. Following in the footsteps of Hubble, other space telescopes like the Chandra X-ray Observatory and the Spitzer Space Telescope have extended the vision into the universe, observing it across various wavelengths. This creative approach has enabled astronomers to delve into realms invisible to the naked eye, unveiling secrets like space dust and emissions from black holes. Recent advancements in space exploration have brought them groundbreaking tools like the James Webb Space Telescope, which soared into orbit in 2021. In Michio Kaku's words, this remarkable telescope stands out as the most potent one ever crafted. Its finely tuned instruments allow it to gaze upon celestial objects that are incredibly old, distant, or faint, far beyond what the Hubble Space Telescope can capture. This ability is vital for unraveling the mysteries of the early universe, tracing the birth of stars and galaxies, and even considering the existence of life on distant planets. Meanwhile, here on Earth, technological steps have given rise to a new generation of colossal observatories, including the European Extremely Large Telescope and the Giant Magellan Telescope. These observatories boast adaptive optics, enabling them to equalize the blurring effects of Earth's atmosphere and capture images with the same transparency as those taken from space. Expanding beyond optical telescopes, advancements in radio, infrared, and X-ray observatories have revolutionized the understanding of the universe. These tools open windows to previously hidden realms, allowing astronomers to detect and examine events such as cosmic microwave background radiation, stellar nurseries, and the aftermath of supernova explosions. Yet, amidst these triumphs, one mystery looms large: dark matter. This tricky substance comprises a crucial portion of a galaxy's mass, yet it escapes direct detection as it neither emits, absorbs, nor reflects light. Instead, its presence manifests through gravitational effects on visible matter, radiation, and the grand variety of the universe's structure, leaving astronomers to ponder its deep mysteries. In the Andromeda Galaxy, scientists have found strong clues pointing to the existence of dark matter. They notice something unusual about how the stars move within it. Normally, they expect stars farther away from the center to move slower than those closer to the middle, but in Andromeda, they all move at pretty much the same speed. This doesn't make sense if only the visible stars and gas were causing the motion. Michio Kaku believes there must be something else at play, something invisible but massive: dark matter. Not only does dark matter seem to affect the way stars move within Andromeda, but it also seems to extend way beyond what they can see with the telescopes. It forms a sort of invisible circle around the galaxy, influencing the movement of smaller galaxies and star clusters that orbit Andromeda. By studying how these objects move, scientists can get a sense of how much dark matter is out there and how it's distributed around the galaxy. It turns out there's a lot of it, stretching out for millions of light years from the galaxy's center. But dark matter isn't spread out evenly throughout Andromeda. It's denser toward the center and thins out as they move away. This lopsided distribution has big implications for how stars and gas clouds form and evolve within the galaxy. Dark matter's gravitational pull helps shape the beautiful spiral arms of Andromeda and even influences where and how quickly new stars are born. Dark matter doesn't just affect Andromeda on its own, though. It's also going to play a major role in a cosmic showdown between Andromeda and our own Milky Way galaxy. When the two galaxies collide, their immense circles of dark matter will interact, shaping the eventual fate of the merged galaxy. Chapter 6: The Future of Space Exploration. Space fans love sharing pictures, stories, and chats about the galaxy. They reach out to people who might not usually get into science stuff. This sharing of knowledge makes a cool community of space buffs. But what's next for exploring the Andromeda Galaxy? Going there in a spaceship isn't happening anytime soon. Michio Kaku says it's just way too far from our Milky Way. But scientists are already dreaming up missions to study Andromeda in super detail. They're jazzed about new telescope tech. After the James Webb Space Telescope, they're planning even better ones. These telescopes will be super sharp, letting scientists check out individual stars, planets, and other space bits in Andromeda way better. Their big goal is mapping out everything about Andromeda: its big part, its small part, its bulge, and all the little galaxies hanging around it. By doing this, scientists hope to get how it's built and what it's made of. This information could help them understand how galaxies form and change, adding to what they know about the whole universe. Their next big aim is to hunt for planets outside our solar system in the Andromeda Galaxy. Scientists are planning to use really smart tools and techniques to find these planets orbiting stars in Andromeda. They want to look at what these planets are made of and what their weather is like. Michio Kaku mentioned that this could help them figure out if any of them could be a new home for life, which would be super exciting because it means life might not just be in our galaxy, the Milky Way. They're also curious about how stars are born and how they die in Andromeda. By watching these events happen, scientists hope to learn more about how galaxies like Andromeda live and change over time. Right now, humans or robots can't go to Andromeda because it's just too far away, and the technology isn't advanced enough. But maybe in the future, they'll figure out how to send special space probes there. These probes would need to be super fast, maybe even going close to the speed of light. It sounds like something out of a science fiction movie, but it's something scientists dream about because it could unlock so many secrets of the universe. But as they dream big and explore further into space, they have to think about how it affects our planet. Space exploration is awesome for learning new things and making cool inventions, but it also has some downsides. When they launch rockets into space, they release chemicals into our atmosphere like chlorine and alumina, which can be bad for the air we breathe and for the ozone layer that protects us from the sun's harmful rays. Space missions create a lot of mess in space. They leave behind a bunch of stuff called space junk. This junk includes things like old rocket parts and broken satellites. It floats around the Earth fast, and that's a problem. Could crash into working satellites and spacecraft, causing big trouble. People are trying to keep track of all this junk and clean it up, but there's so much of it that it's not easy. When spacecraft visit other planets or moons, they might bring tiny living things from Earth with them. That's not good because it could mess up the new place. Imagine if they're looking for alien life, but they accidentally bring Earth life and confuse everything. So, before launching, they have to make sure our spacecraft are super clean and follow rules to keep from contaminating other planets. Did we know that space stuff can also mess with our nights? Those satellites and big groups of satellites for internet use reflect sunlight to Earth. It's like having a bunch of mirrors up there. It makes it harder for scientists to look at stars and messes with animals and people's sleep patterns. They need to be careful about how many satellites they put up there and where they put them. In the future, they might start mining things from space rocks like asteroids or the moon. That sounds cool, but they have to be careful not to mess up space even more while doing it. Michio Kaku said mining in space might lessen how much harm they do to the Earth's environment, but it brings up concerns about whether it's right or not to take resources from other planets or moons. It's important to create rules and tools for mining in space that make sure they do it responsibly so they don't damage these places that haven't been touched by humans before. If they figure out how to mine in space without causing too much harm, They can make sure that exploring space helps them learn more about the universe without hurting Earth or anyone else out there. What are your thoughts on Michio Kaku's revelation about the James Webb Telescope receiving alarming signals from the Andromeda Galaxy?